Hi there, folks, and welcome to another update on the volcanic eruption occurring in Iceland. I am Geology Professor Shawn Willsey. Today is Tuesday, March 19th. It is about 10:15 a.m. here Mountain Daylight Time. That would make it 4:15 over in Iceland or UTC time. Thanks again for joining me. Our plan for today is to provide a brief update. I'm actually in an hour break between classes here, and I do leave tomorrow for my vacation to Europe, but I thought there was enough interesting things happening that I did want to put together a quick update and let you know some of the things that have been going on. And I want to start out my update today by offering an apology and a correction over yesterday's update on March 18th on Monday. I think the title that I chose for that video and the thumbnail title were a little bit misleading. And as it sort of just sat with me during the day and I kind of thought about and looked at the data a little bit more, I thought this was probably the wrong impression or the wrong conclusion. And so it was presumptuous of me to assume that the eruption was winding down. We can clearly see that this eruption is sustaining these, fairly low but active levels of eruption. So I just want to make that a public apology there, that I didn't mean to be misleading in suggesting that the eruption was about to end, because for all I know, this could go on for many more days and possibly longer. So thanks for forgiving me on that regard. Um, so we can see here with the webcam that the activity has still been sustained at the south end of the fissure. It's producing these spatter ramparts. So as the eruption is throwing out these clots of lava around these segments along the fissure, that's building up these ridges of lava or cooled lava along the margins. This one here is nearly forming a cone, but it's not quite there yet. And in the days to come, if this continues, these might actually turn into spatter cones. But right now, this one in particular here in the middle is more like a spatter rampart, as are these here, because we can see there's clearly eruptive material piling up on one side of the vent, possibly from the predominant wind direction. If a lot of this airborne lava, this spatter, ends up falling on one side of the vent versus the other, then you're going to end up building that side and producing more of an asymmetrical sort of topographic feature there. So there's the webcam view, and I'm sure there's others, but again, this is a very brief update, so I'm gonna move through this pretty quickly if that's okay. Um, let's actually go. I did receive on my Google Earth. I want to thank a couple of viewers, David Gunzler and John Ingalls sent me some shape files, some KMZ files that I could use for Google Earth. And so I'm very happy to be able to include those. So thank you, both of you, for sending those. So you've seen in the past where I've had the lava flow fields on the map here. And so if we add the December 18th flow field and the eruptive fissures, that looks something like this. And then the January 14th eruption, which was further south near town, would be this area here shown in pink. And then if we add the February 8th eruption, that's this one here shown in red, largely overlapping and overprinting portions of the December flow. And again, these viewers just sent me some of these shape files indicating the actual extent of the lava flow field for this March 16th eruption, the eruption that began on March 16th. So I can add that one as well, shown here in blue. And so that shows up really nicely. So again, thanks to those viewers who have those Google Earth and technical skills that I have not learned yet, and were able to send those to me. And the nice thing here is you actually can see where it flowed over the top of the February flow here, largely followed almost precisely, but also extending further out that February flow field, which is outlined in red here. And then we can add in, so the little Google Earth file continues to grow. There's the defensive berms, the barriers that have been built around. And then I've got other things here too, but that's probably good for now. So thanks for both those viewers for sending those to me. Those have been very helpful. And just as a quick update, this southern flow front here has not appreciably advanced over where it was yesterday. So it still is not at the road. It's still a couple hundred meters from the road. And given what's happening currently, it's hard to say if it's ever going to make it there because it's moving so slow. The front of this thing is an lava flow, which is a very slow moving type of flow front. And really, it's just a question of if get rid of these here real quick, if this eruptive fissure here, the amount of lava that it's supplying If it's just not quite enough to carry that lava that distance and continue to supply lava to the flow front to make it advance, then it might just be stalled out permanently. But we'll have to see in the days to come. Um, this is the only active part of the vent currently, is this little section right here, from the southern extent of the flow field. We can see there's this shield volcano here that a lot of the flow went around. This flow here to the east, as far as I've heard, it's pretty much stalled and stopped. And it's really in sort of no man's land with nowhere to go. So that one's not going to be a big player or a newsmaker. And then I haven't seen any estimates yet on either the volume of the total, well, the volume of output, how much lava is being erupted. Not just, well, one, either the total amount and also just the output, the discharge, the cubic meters per second, if you will, of lava that's being put out at this point. So those will be interesting to see if and when some of those numbers come in. But just wanted to share this new map view we have here, which I think is very helpful, definitely helpful to me. Let's go to the Met Office update. And this was as of this morning around just before noon Iceland time. So the eruption now has lasted longer than the last 3 eruptions. So far this eruption is gone on longer than the January and the February eruptions. And I suppose the December one too. The December one lasted about 3 days, but it was pretty much in its last gasps at this point by the time we got to day 3 or so. Land rise continues in Svartsengi, which indicates that magma is still flowing from depth into the magma accumulation zone under Svartsengi, as well as feeding the eruption. So that's interesting. And let's continue on with the update, and then we'll get to this graphic down here. The eruption continues. Let me make this a little bit bigger for you. Maybe that's a little better there. The eruption continues and has now lasted for over 2.5 days and has become longer than the 3 eruptions that occurred in the area since December 2023. It continues to erupt in the same places as yesterday afternoon, which are south end of the fissure. Crater rims continue to build and some magma jet activity remains. So it's pulsating a little bit. It's building up those spatter ramparts and those edges around the vents. The edge of the lava, which was about 300 meters from the south road yesterday, does not seem to have moved forward since yesterday, so it seems to have stalled. Lava flow from the craters remains mostly to the south, so most of the lava is being directed in a southward direction. But active lava margins flow on top of what flowed at the beginning of the eruption. So some of these lavas are stacked on top of each other, which makes it difficult to tell what's going on and how much lava is traveling in any given path. No seismic activity and around the magma tunnel since the eruption began. But eruption turbulence is measured and it's been quite stable for the past 2 days. So that's like maybe harmonic tremor and just some of the seismic signals we get when there is an eruption taking place. And so the stability indicates that the power of the eruption has not decreased. When magma flowed from Svartsengi across the Sunnuks crater series on March 16th, the land in Svartsengi was as sticky as when previous magma tunnels formed. Maybe a little bit of Google Translate there. They've only got this out in Icelandic as far as I know. GPS measurements and satellite images since then show that land rising continues in Svartsengi, which suggests that magma is still flowing from deep into the magma reservoir beneath Svartsengi, as well as feeding the eruption. So the idea there is we have evidence, and we'll get to the graphic here in a second, that inflation has resumed, that underneath the power plant region, the land is rising, suggesting that magma is still coming up from a deeper source. And even though some of it's erupting right now, as we can see, the amount that's erupting is less than the amount that's accumulating in the subsurface, and that's why the land is rising. It should be kept in mind that relatively few measurement points have been obtained in the short time that's passed since the eruption began, and the measurements are always subject to uncertainty. So not much data to suggest that, but this preliminary data is suggesting that. This will, of course, be either more concrete in the days to come as we get more data, or possibly future data might refute that suggestion, and maybe there isn't as much uplift occurring as we suggest or can think it might be right now. Okay, so then they have the graphic here showing the amount of uplift between March 17th and 18th after the eruption began. So you can see this more or less delineates, as best we can tell. This is the best handle we have on what the extent and location of this shallow magma body is. So here's the power plant and Blue Lagoon area right here. There's obviously this new lava flow in red. The gray lava flows are some of these older ones. Here's Grindavik down here. And so you can see upwards of 20 millimeters of uplift, 2 centimeters since the eruption began on March 17th. So even though you were erupting this magma at the surface with this eruption, it seems that the amount of inflow into that shallow magma reservoir is outpacing it to some degree. Again, these are just kind of preliminary measurements. Gas emissions have been reduced. Still, there's a chance that gas pollution will be noticed, and southwesterly winds, and that's kind of it for the update so far. So hopefully that's helpful there. This satellite imagery here just illustrates the ground deformation, but we'll also look at the GPS data here in a second. Earthquakes, not much to report, as you'd expect once you have an eruption that's progressing and proceeding and in the works. Here's Grindavik here, and the eruption site is more or less in this area, and there's absolutely no earthquakes over the last 24 hours in that region. So pretty easy story there. If we look at the GPS data, some interesting things here. Let's maybe come down to the 4-hour plots, because those will give us a few more data points. So let's go to Svartsengi first. And again, this is just where you have to like close one eye and cock your head to the side and decide how you want to interpret this data. But as you look at the GPS data showing the elevation of the land and how much it's risen or fallen, we can see the steady uplift that occurred all through February and into the first half of March. And then here's our March 16th eruption where the land dropped to some degree. And then we have this cluster of, maybe 12 points here. And how would you interpret that? That's sort of what we're kind of left with there. Is there an upward trend in that data? Hard to say, especially with the error bars. I think if this was the only data point, I would be pretty reluctant to make that conclusion. But I think this, combined with the satellite data, is at least suggestive that inflation and land uplift is going on. A lot of points kind of all over the place there. And it'll be interesting over the next couple of days as this lengthens, we should get a more clearly defined trend established there. But let's check out a couple other stations as well. Let's go maybe to, I don't know, the one, this is Thorbjorn, the hill just to the north of Grindavik. So this would be sort of on the southeast flank of the magma body. And this one, a little bit less. This one, if you told me that was pretty much flatlined, I would be okay with that. But again, the error bars are wide enough here and the data points are so close together that it's just really hard to tell what's going on there. We also need to keep in mind the scale here. So one tick mark to the next on this graph is about 50 millimeters or 5 centimeters, about 2 inches. And if we go back to the one we were on previously, that one's the same. But sometimes they use different scales on some of these graphs. Like, for example, this one. So this one has a little different scale where between each tick mark it's 40 millimeters, so less. So this one's a little bit better resolution. And if you come into this specific station and look at the trend, that one does look a little more like it's inflationary trend where it's actually moving upwards over time. So, but that's what the data shows. The data's, the observations we should all agree on what the dots show and what they are, but how we each interpret those and spin those, that's where the subjectivity that comes into this. So hopefully we'll see a better trend to that GPS data moving forward, but it may suggest a slight inflationary trend, not definitive, but I think when you combine that with the satellite ground deformation data, it's at least more strongly suggestive of that, but by no means particularly, absolutely concrete, conclusive. In the news, the town's opened again to residents and people have businesses there. So that's good news now that they've got, here's this flow that goes off to the east. The town's over here, and so with the flow pretty, even though the eruption continues and the flow pretty well contained, it seems like they're going to keep the town open, at least to those residents and people who have business there, especially with the little fishing port there. And then I thought this was kind of a fun little data point. So today, March 19th, marks the 3-year anniversary of when we had eruptions in the Reykjanes area. So it was 3 years ago today, March 19th, 2021, that the first series of eruptions at Fagradalsfjall, just to the east of this area we're focusing on now, started to take place. So we had eruption there in 2021 that lasted for 6 months or so. There was another one in 2022 that I was able to visit. This is the 2021 eruption here. I mean, you can see this was, I don't know if we'll ever see an eruption that was quite this tourist friendly. The fact that you could get, oops, sorry, here I'm trying to make that the right size. There we go. The fact that you could jump off of your plane at an international airport, jump in a rental car, and within 30-40 minutes park and hike up the hill and be able to get this close to an erupting spatter cone. That's a nice little spatter cone there, and this close to the lava is pretty remarkable, and that's about as good as it gets, I would say. So kind of a cool little data point there. For the first time in 800 years on the Reykjanes, the eruption began in 2021. There was 2022, 2023, so we had 3 in the Fagradalsfjall area, and now we've had 4 north of Grindavik. So 7 eruptions in total in exactly 3 years in this region. Pretty amazing. So, okay, so this was a brief update, like I mentioned. I'm between classes here. So what's our takeaway? I think this is sort of a wait and see period in terms of what will happen next. We want to probably just wait and see how much longer the eruption continues at this intensity, what the duration is. It's been doing this level of activity for at least 24, maybe 36 hours. So will this continue for days to come, or possibly weeks to come? And what will be the response, or what will the ground deformation data show us while this is going on? Will we continue to see inflation of the magma body that's feeding this eruption? Because clearly, if it's inflating, it's storing some magma and not moving all that magma through the system. So it may be confined. There may be a choke point or a pinch point that all the magma can't get through. It doesn't have a clear avenue from that deeper source through the system to the surface, and so it's storing some of that magma. There could be some sills and subsurface chambers or reservoirs that aren't connected. So we might be emptying out one sill here, maybe not emptying it, but this is some of the magma that's erupted out taking place now, but we may have other sills. Sometimes these sills are kind of stacked, and I've used graphics in the past to show you how that might look. And so it might not be a good idea to consider this as like one cohesive connected magma body. We may have multiple magma bodies in this area, and if we see inflation continue but while the eruption is also going on, that may be an indicator that we have more than one storage zone for the magma, and one is being recharged from deep and it's showing inflation, while there's another magma storage body that's producing the material for this eruption. So that may be the case, but we'll just have to collect more data. I'm here learning with you. I'm trying my best to give you the best information I can, to give you the best analysis I can. When I'm wrong, I will always admit I'm wrong, and I will just do my best to provide some insights, some geologic expertise as best I can. I'm leaning on others and reading others as well, and I'm learning, taking in all the information I can, and trying to present that to you in a way that is understandable, that's relatable, and that hopefully is helpful to you. So with that, I'll go ahead and sign off. You might get another update or two if something significant goes on while I'm on vacation. Otherwise, please enjoy some of the other videos I'll put out in the meantime. and I will hopefully be back with you soon. We'll probably do a live stream that first week in April, and I have some fun interviews planned that I need to get on the board as well. So with that, thanks so much for supporting the channel. Be sure to like it and make sure you're subscribed. Thanks for your support here, team. I appreciate you. Thanks for learning with me. Take care and goodbye.